Hey guys, Mr. C here with the TestTube. Today is our very first video that we're actually going to do, our very first educational lesson video, and it's going to be on stoichiometry. We've got a couple things we're going to talk about. Over the course of time teaching stoichiometry, chemistry, and all of that, I've come up with 3 simple steps in order to help us get from the mass or moles of a reactant or even a product, and to go to mass or moles of a product or a reactant. So we can go backwards or forwards with stoichiometry in figuring out how much we started with or how much we want to get. Before we get into the meat of what stoichiometry is, I want to point out something with this chemical formula here. These, and I know the glucose doesn't have anything in front of it, we can pretend there's a 1 in front of there, but each one of these has these coefficients in front of it. That's what we call the number in front of the chemical formula. It's a coefficient. This is actually a ratio of everything to one another. So for every one thing of glucose we have a ratio of 1 to 6 with O2, and we can continue it further from there. So for every 1 molecule of glucose, I have 6 molecules of O2. I produce 6 molecules of CO2, and I also produce 6 molecules of H2O. Now we can actually say this in moles as well if we want to. So I can say for every 1 mole of glucose, I react with 6 moles of O2. It yields me 6 moles of CO2 and 6 moles of H2O. So, when we have this down in our heads, this is actually kind of nice and it helps us out. These are called the mole ratios. And these are going to help us out with one of our 3 steps that I'm going to show you guys in just a moment. Okay, so our steps that we're going to take. Now, I said 3, we actually technically kind of have 4. I'm just going to call it step 0. This is what you should do every single time you come up with or are given a chemical formula. So, step 0, make sure the formula is balanced. That is always, always, always the very first thing that you need to do. Now, we'll probably cover later on in our time with all of this, a video showing you guys how to balance equations. But for now, I'm going to assume that you all know how to do this. If you need to figure it out or if you need help with balancing stuff, there are other good YouTube videos out there that help out with this kind of thing. Alright, step 1 in this case. Step 1, we want to convert the given amount of whatever it is. So let's say we're given grams or given moles of glucose. We want to convert this amount to moles of the reactant. So, you may be given moles, and sometimes you may be given liters, a volume of some kind, if we're working with gases, but that's for later. We want to convert whatever that is, convert that amount of reactant to moles of that reactant. So, in the future, for this example, we're going to convert moles of glucose, or grams of glucose, to grams of CO2. This is going to be a mass-to-mass conversion that we're going to be looking at here, but we'll get to that in just a few. Alright, step 2. So, like we talked about earlier, we're going to want to use this mole ratio here. We want to use this mole ratio to convert the moles of the reactant to the moles of whatever we're trying to figure out. So in this case, we're going to be going from a reactant to a product. We're going to want to convert the moles of our reactant to the moles of our product, whichever it is we're going to be solving for. So, use mole ratio to convert, that's an R, to moles of product. Step 2, done. Alright, step 3 now. Step 3, the final step to this, we're going to use the molar mass of our product and convert from moles of our product to grams of our product. Now, if you just want to figure out the moles of your product, then you can just stop right at step 2. You're done. However, we're going to be showing you guys a mass-to-mass equation, so we're going to want to use step 3 and convert the moles of our product, the moles of the thing that we are trying to solve for, into grams of our product. Alright, step 3. And PROD is just product. I just shorthanded it because I'm lazy. Okay, so if you've been with us this far, we've gone from steps 0 to 3. I'm going to give you guys a little roadmap to help you out just a little bit in remembering how we actually go from grams to grams, or grams to moles, or moles to grams, whichever way you want to do it. So, we started off with glucose here, so I'm going to label this substance A. It's the thing that we started with. Thing A, substance A, chemical A. It's fine. And whatever we end with, I like to label it substance or chemical B. And since we ended here with CO2, I label that B. Now, to get things going here a little bit, we're going to start, typically we're going to start with grams of thing A, substance A. And we're going to convert that to moles of substance A. And from there, we convert this to moles of substance B. And finally, we end with grams. Alright, so we can say grams to moles, moles to grams. Now, my students have heard me say this a bajillion times. If you remember grams to moles, moles to grams, you will not forget how to convert mass to mass or mass to moles or whatever. So, to kind of help out here, how do we go from grams of A to moles of A? Well, just divide by the molar mass, which is this mm here. It's not millimeters, it's molar mass. Mm of substance A. And that will get you to moles of A. Now, going from moles of A to moles of B, what we need here is the mole ratio of B to A. So, for this, we have moles of B over moles of A. Hopefully you guys can see here how these things cancel, how the units cancel out. Now, going from moles of B to grams of B, all we need to do here, we need to do the opposite of what we did at the very beginning. And we want to multiply, which is this little x here, multiply by the molar mass of B. And that will get us to our final answer. Now, sometimes you may be given moles of A and you want to find grams of B. Well, you can just go ahead and ignore this entire part right here and just start right at moles of A. Or sometimes maybe you'll be given grams of A, but you want to end with moles of B. That's fine. You can just ignore this final part here and just go grams to moles to moles. That's okay. And essentially, this is all stoichiometry is. It's just going from some starting amount, mass or moles, into some final quantity, final amount. So, hopefully that helps you guys out. Okay, so the question we are being given here now, what we are being asked of is convert 856 grams of C6H12O6, or glucose, to grams of CO2. So this is a mass-to-mass conversion. It's pretty common in chemistry, especially in upper level chemistry, because you want to figure out how much of something you're going to make in this reaction. In this case, we care about CO2, water, whatever. Alright, step 0, we need to make sure that we have this thing balanced. So, if we look at it, I know it's balanced because I balanced it, so it's pretty much perfect. So we can just go on right ahead to step 1. Alright, step 1, we know we start with 856 grams of glucose. we want to convert the grams of glucose to moles of glucose. Because if you remember, step 1 is convert whatever amount of what you're starting with into moles. So we can do this really easily using the molar mass of glucose. So if I have 856 grams of glucose, and I'm shorthanding the C6H12O6 to GLU because I'm lazy, we want to use the molar mass of glucose in this equation. And I've conveniently already figured it out beforehand. So for every 1 mole of glucose, you have 180.2 grams of glucose. Now, we're dividing by the molar mass. We know that the molar mass of something is grams per mole, which means grams over moles. So, if we use the molar mass, which in this case, molar mass, we have it flip-flopped, so we're dividing by the molar mass. Equivalently, we're saying for every 1 mole of glucose, it weighs 180.2 grams. So, we can use this, and we can see here that the units actually cancel out. That's what we want to do here. We want to get this into moles of glucose. So if we do this and punch it into our handy-dandy calculators, you will find that you get 4.750 moles of glucose. 856 grams of glucose is actually 4.750 moles of glucose. Alright, so that's step 1 done. We took our 856 grams of glucose, divided it by the molar mass of glucose, and we get 4.750. Step 1, finite. Alright, so we found out in the previous step that we have 4.750 moles of glucose. Now, step 2, we want to convert that to moles of our product that we're solving for. If you remember, we are trying to go from glucose, mass of glucose, to grams of CO2. Alright, so now in our step 2, we are starting with 4.750 moles of glucose. Now, remember with step 2, we want to convert moles of glucose to moles of CO2. So, we want to get rid of this moles of glucose and finish the step with moles of CO2. So, how do we do that? Well, we use our mole ratio. We're going to use the ratio of moles of CO2 over moles of glucose. Why? Well, because if we have moles of glucose on top and moles of glucose on the bottom of this fraction here, they cancel each other out. Alright, now what numbers do we put in here? Well, we use our mole ratio. For every 6 moles of CO2 that we produce, we started with 1 mole of glucose. So, I'm going to put a 6 up on top because we have 6 moles of CO2 that we're starting with. And we use 1 mole of glucose. So it's 6 over 1. So essentially all we're doing is multiplying 4.750 by 6, but I'm showing you guys this with units because you need to use these units in the future. They help you keep track of your equation. They help you keep track of everything. It makes it nice and neat and clean. So we get 28.50 moles of CO2. Voila! Step 2 done. Step 3, we're going to start with our 28.50 moles of CO2, and we want to convert this to grams of CO2. And all we need to do here is just use the molar mass of CO2, which I beforehand calculated for you guys. So, in this case here, we are going to use the grams per mole style that we didn't use prior. The last time we actually did moles per gram, but we're going to use this one here to get us our final answer. So, for every 44.01 grams of CO2, we have 1 mole of CO2. So, again, our units are going to cancel out. The moles of CO2 cancel out, and we're left with grams of CO2 up on top, which is exactly what we were looking for in the first place. Now that we have this, so we're going to get to our final answer in this case of 1,254 with the decimal place there, It's for significant figures, so that'll be in another video. Grams of CO2. Now, if we don't like it that way, we can put this into scientific notation. If we just take this and move it 1, 2, 3 places over, like this, we can say 1.254 times 10 to the third grams of CO2. Either answer works, either answer is perfect. And that is step 3. Alright, so now we have a new problem here. Now we want to convert 6.23 moles of H2O to grams of glucose. But notice here, we're starting with a product and we're converting to a reactant. So essentially it's like saying I've already done the reaction. I didn't know how much glucose I started with, but I figured out how much H2O I made at the end of it. So how much glucose did I actually start with? That's the question we are essentially asking here. But mathematically, we don't care about that. All we care about is converting is moles of H2O to grams of glucose. So let's see how we can do that. So we can skip step 0 because we already have this thing balanced. And we can also skip step 1 because we have our very first thing in moles already. We have 6.23 moles of H2O. So we don't need to convert that to moles. It's already done for us. Now, what we need to do, we just start at step 2. We start converting moles of what we're given. So I'm going to call this guy here A. And I'm going to label glucose as B. So now that we've established what we have started with and what we're ending with, let's begin. So we are going to start with 6.23 moles of H2O. And remember, I said we could skip step 1 already, converting it into moles. It's already done for us. So just step 2, start with the mole ratio. Now, we want the ratio of B over A, or the thing we're solving for, over the thing that we start with. So we're going to take 1 mole of glucose over 6 moles of H2O. And this should make sense because the moles of H2O on top cancel out the moles of H2O on bottom, leaving us with moles of glucose, which is exactly what we were looking for. And once we do this, we find that we get 1.04 moles of glucose. Step 2 done. Now with step 3, finishing this off, we know we start with 1.04 moles of glucose. We know we need to convert this to grams of glucose using the molar mass of glucose. If you were taking notes earlier, you would remember and see that we need to use the molar mass of our product or whatever we're solving for to find this out. So let's actually visualize this. We have 180.2 grams of glucose for every 1 mole of glucose. Now, we know we're going to end up with grams of glucose because the moles on bottom cancel out, and we're left with grams on top. Plug this into your calculator, and you get 187 grams of glucose as your final answer. In the end, this is what you guys need to remember. We have 3, technically 4 steps. Step 0 is just make sure your equation's balanced. Don't ever go into a question without a properly balanced equation, unless in the instructions it tells you don't worry about balancing it. Sometimes they do that. Step 1 is convert your mass of what you start with into moles by dividing by the molar mass. Step 2, use the mole ratio of what you're solving for over what you're starting with to get moles of what you are solving for. And step 3, we're going to use the molar mass of what we have solved for. So in this case, I use the molar mass of glucose, because that's what I was looking for, to get it into grams of glucose. Alrighty. Thank you so much for watching this video. We hope that it helped you out a little bit. Stay tuned for part 2. That's going to be on the way. Part 2 is going to be covering limiting and excess reagents, and part 3 should be covering yields, percent yield, actual yield, theoretical yield. Alrighty guys, thank you again. Please click the like button, subscribe, do all the YouTube things. And for daily science updates, follow us on Instagram at TestTube Science. Alrighty guys, have a good day. We'll see you in the next video. So sorry I can't write perfectly. That is terrible. That is just god awful. Let me be lazy, woman. There you go. Yes, question. Noodle soup. La 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 la.
Wait, why do you erase it?
Because I'm going to the equation now.
So you wrote it up there and it's just gonna flash on the screen and then you're gonna move on, or did you talk about it at all?
No, I talked about it. It's literally what I was doing.
Well, after you wrote product, like the UCT, did you say anything?
No.
No, it's fine. Don't worry.
And use instead blah blah blah. Gonna community. Terrible. Shh. Quiet down in production, okay? So, step 1.
Well, say okay so to the camera. It's like your back is facing the camera.
Okay, so step 1. Okay, so if you're going to convert the 6.2 moles of H2O.
Worry about. It's fine.
So, let me get my train of thought here, because I lost it. This is why Mrs. Caniglia writes everything. See, that's perfect. This is crap. Woman, come on! This is so weird. Did you ever watch the Powerpuff Girls?
No, I watch cool stuff.
Step 2, which is what we're on, we're gonna start with 4. Hey, you know what? You're not the expert here, alright? I'm the expert. I got my degree.
You just sound very angry.
We're gonna go to the final answer! The final answer! So we've labeled H2. Shut up. You're ruining it.
Calm down, boss.
Final answer.
Oh, shush me.
I will. Whoa, this is a kid's show. We can edit that shit. Who cares? Alright.